So what's up, guys? Good evening, a good afternoon, a good morning, and a good night whenever you are watching this video. So I apologize to you that the previous video had some sound problems. It captured two sounds, so I'm really sorry for that. And today we will be learning mole concept 2. Basically, it will deal with stoichiometry and uh, uh, that redox reactions. Okay, and in this chapter, this is a chapter to understand. So you have nothing to no formulas basically. So I will be teaching today by the use of questions. I'll solve many questions, and at last I'll give two WBG questions to you to solve. So let's start our WBJ course mole concept 2. So what is the first question? But first let me take the pen. So here a reaction is given, you know the reaction, and the question is find out the equivalent weight of KClO3. Okay, in respect to this reaction, and your options are A 18.2, B 20.4, C 25.6, and D 30.4. Okay, pause the video, solve yourself if you can, and write the answer in the comment box. Okay, and I am waiting 1, 2, 3 and starting to solve. So what is equivalent weight? You know equivalent weight is equals to molecular weight by n factor. I have taught you n factor in the general video. See, first remember one thing, oxygen's electronegativity is always greater than chlorine's. So wherever these two will be combined, oxygen will always be in -2 state, which is its basic state, and chlorine can be in any other state, +6, +5 and all. Okay, since oxygen is more electronegative than chlorine. So what is the total charge on oxygen? So it is in 2- state into 3, that is -6. K is always as usual +1. So to make it neutral, Cl must be in +5 state, and which it is, and it gives Cl in -1 state, and K as usual +1, and oxygen in 0. You can calculate the n factor with respect to oxygen and chlorine, but with respect to oxygen you first need to balance the number of oxygen atoms and do all those. So I will say don't do that one, always choose simpler atoms like chlorine. What is the change in oxygen state? +5 to -1. So how much electrons has changed? 6. So n factor is 6. So n equals to 6. What is the weight of KClO3? 39 plus 35.5 plus 3 into 16, 48. So 48 plus 60, 108 plus 9, and 117 plus 5, 122.5. 122.5 by 6. So it basically gives 2. 6 into 2 is 12, 2, and 0.25 means what? Sorry, 25 means what? 4, and 10 means 1, 20.41. So answer is B. So I hope you have got the right answer. And do one thing, just when you are starting to see the video, tell me when you are starting to watch the video, and when you will be giving the answers by yourself, I can access how much time you are giving the answer. Be honest to yourself. If you solve this question by yourself, it will boost your morale, and if you can't, watch carefully how I am solving, and that's all. Now second question, balancing. I have taught balancing, but this is a bit more difficult balancing, where I will say you what is the problem. See, in the product the oxygen is coming from only one reactant, so you have to simultaneously balance these two with this one. That will be a difficult job. So don't choose oxygen atom first to balance. Choose an atom in the reactant that is present in only one reactant, that is NH3, and the product, in the product it is only in one of the products, that is H2O. So H, so I am starting my balancing with respect to H. It is even, that is odd. First make both even, multiply here by 2. Okay, so 6, we multiply here 3, so 3 into 2, 6. Okay, the question is, what is the coefficient of O2 in the balancing? Okay, option A is 4, option B is 5, option C is 6, option D is 3. So what is 2 and here it is 3. Okay, now see, now you come to hydrogen atom. Hydrogen has done. Now you see oxygen. What is the problem of oxygen? Here is 3, here is 1, 4, and here also even. So you may say, you may think to do it first, but see here N is only in one place here, and here also in the product one place. So first balance N, so 2, so 2. Now you see it is odd, 2 oxygen plus 3, 5 oxygen, and it is even. Make it a fraction. So first divided by 2, and how many oxygen you need? 5, so 5 by 2. Now multiply the fraction, so it is balanced. 4 NH3 plus 5 O2 gives 4 NO plus 6 H2O. This is a very important reaction of Ostwald's process, so the answer is 5, means option B. Let me see who got it correct. Never start with O. That's my simple point. I wanted to make you understand. Choose simpler atoms that are required. More complex balancing are there. Okay, and questions come from balancing. That will be not that this much easy. That will be much more intricate and much more difficult. Okay, have a clarity in mind and start with one atom that is unique. I said. Second question is gastric juice. See, where is the pen? Okay, so it's there. Gastric juice contains 3.65 gram of HCl per liter. If a person produces 2 liter of gastric juice per day, how many antacids tablets, each containing 520 milligram of AlOH3, are needed to neutralize all HCl produced in one day? Okay, so the options are A, 7 tablets, B, 3 tablets, D, 10 tablets, D, okay, C I am giving here, C is 8 tablets. Okay, solve and write the answer. I am starting. First you have to calculate this one by means of equivalents, and how to do that? You will do millimole, milligram equivalent, millimole equivalent, or what equivalent? I will be teaching you that. First come to AlOH3. What is its N factor? What is the N factor of this? Is 3, because Al 3 plus, total positive charge on the cation. So it is 3. Okay. Now next. So equivalent weight equals to molecular weight by 3. So first let me calculate that one. Al is 27 plus 3 into 17, 51 by 3, that means 78 by 3, that will be give you 20, I think 26, right? Now see each how much molar equivalent each tablet is having. So how can you do that? 520 by 1000, because it is in milligram, you have to make it in grams, by its equivalent weight. Okay, so how much it will give? It will give you 0.52 by 26, it is equals to 0.02 molar equivalent each tablet. Say you need X such tablets, X into 0.02 is the total molar equivalent. That will neutralize what? 2 liters of HCl. And 2 liters of HCl, not 2 liters of that gastric juice containing 3.65 gram HCl per liter. What is the N factor of HCl? 1, because 1 replaceable hydrogen. Okay, so wait a bit, I need okay, so it is 1, N factor is 1. So what you need to do, is you have to calculate the normality. Okay, so first of all calculate the molarity 6.65 by normality. You can directly calculate by dividing by equivalent weight, like this here we have calculated. So what is this molecular weight of HCl? 36.5. What is this mole factor? 1. So it is generally 0.1 molar equivalent. How much liter of water is of that gastric juice is present? 2 liters. So total molar equivalent is 0.2 equals to 0.2. So how many tablets you are requiring? 10. So 10 tablets you need to neutralize all the gastric juice. If you neutralize all gastric juice, your food won't get digested. So it's 10. Okay, 10 tablets. Now come to the next question. What is said in the question? First read. Why the pen? Okay. What volume of 0.25 molar H2SO4 is required to neutralize 1.90 of a mixture containing equimolar note it, equimolar amounts of sodium bicarbonate and sodium carbonate. Okay, what is the meaning of equivalent amount? Means you have to divide this one in such a manner that the mole of these two will be equal. Say if it is in 0.23 molar, this must be also 0.23 mole. Okay, you have to divide in such a way. This I have taken as example. So in what ratio we will divide this one? We will divide this one in the ratio of what? Equivalent weight? No, molar weight, molar mass. Molar of mass of NaCO3 is 23 plus 1 plus CO3, you remember. Okay, it's 60. 12 plus 48, 60. You remember this one. This will be very helpful to you. So it's basically 84. So 84 is to, this is 60, this is 46, means 106. So how much NaHCO3 is present? How much NaHCO3 is present? 84 by total is 84 plus 106, 190. See, there is, the amount is given in such a way. So calculations are easy in WBJEE, but you need to get the logic and do it fast. So this is basically 100. So 0.84 grams of sodium carbonate is present. Let me find out the equivalent weight, okay, and number of gram equivalent. What is the equivalent weight of NaHCO3? Its molecular weight by N factor. What is N factor? 1. Total positive charge on the cation is 1. So how many molar equivalent? 0.84 by 84 is equals to 0.01. And now come to Na2CO3. It is similarly 1.90 minus 0.84. It will be 1.06 grams. What is equivalent weight of this one? 106 by N factor 2, because to how much charge, total charge on the cation is plus 2, plus 1 into 2, so it's 2. So equivalent weight is 53. So divided by 53, it will give you how much? 0.02 molar equivalent. Now to find out molar equivalent of H2SO4, you see I am taking X ml of H2SO4 to neutralize NaHCO3 and Y ml, sorry, why are they happening, and Y ml to neutralize Na2CO3. Okay, so what is the molarity? 0.25. To find out molar equivalent, you always need to multiply with normality. Normality equals to N factor into molarity. I have said you this one. What is the N factor of H2SO4? How many replaceable hydrogen? 2 into 2. This will give you normality. Okay. So X into X into 0.5 by how much? 1000, because normality is in 1000, but we have taken X in ml. Be crystal clear of the concepts. Okay, don't calculate here. It is in millimole equivalent, and you in the right hand side you take molar equivalent, and in the left hand side you take millimolar equivalent. Then your answers will be wrong. Okay, so X into 0.5 by 1000 molar equivalent. and how much it will utilize? 0.01 of NaCO3. So it's basically 10 by 0.5, it's 20 ml. So what is the answer? 20 ml? No, wait. Okay, options I have not given. A is 20 ml, B is 40 ml. Now you know this one. C is 60 ml and D is 75 ml. Okay. Now see, it is 20 ml. You have got X, and Y. Similarly, you can take out Y into 0.5 by 1000 equals to, what is the molar equivalent of sodium carbonate? 0.02. That will give you 20 by 0.5 equals to 40. So what is the total volume you are requiring? That is X plus Y equals to 60. So the answer is option C, 60. So next question. Read the question. I am giving the options till then. Option A, 300 and 700. Option B, 700 and 300. Option C, 200, 800. Option D, 800 and 200. So you have read the question. I am repeating it again. Two acids A and B are titrated separately each time, okay, with 25 molar of N normal Na2CO3. We don't know what is the normality, okay, and how much their volume is required. First, acid A required 10 ml and acid B required 40 ml respectively for complete neutralization. Question is, how much volume of A and B would you mix in one to make it 1 liter, so that the new acid that is forming has the strength equals to this one? Means it will also be N normal. Means if you 25 molar ml of this one will require 25 ml of the new acid, right? So you see how to do this. This is a bit tricky question. First, you don't know what is the normality of the two acids respectively. First, calculate it with respect to the Na2CO3's normality. Say Na2CO3's normality is N, and you have taken 25 ml. This I am doing in milliliter equivalent, sorry, millimole equivalent. That's why I am not divided by 1000. Okay. If I divide it by 1000, then molar equivalent. This equals to, I don't know. Let me say what is the normality of the first acid is X. How much ml we require? 10 ml. So what is X? X equals to 5 by 2 N. X is 5 by 2 N. N is the normality of Na2CO3. And what is the normality? Similarly, N into 25 is equals to Y into 40 for acid B. So normality of acid B is 5 by 8 N, right? Now we need to mix these two in such a manner that the resulting acid is how much normal? N normal. So let me take X liter of A, and therefore 1 minus X liter of B. So you know this how to calculate the strength. I am writing here the formula in box, okay. Strength after mixing two acid is N1 V1 plus N2 V2 by V1 plus V2. New strength in new normality, okay. So how much you have taken? X liter you have taken A into how much? 5 by 2 normal. And how much B you have taken? 1 minus X. And what is the normality of B? 5 by 8 N. What is the total volume? 1 liter. Okay, that is equals to how much normal? N normal. So simple, right? At first it was looking so dangerous, the question, right? Now it has become so simple. So 5 by 2x. So multiply this will be plus 5 by 8, n I am cancelling, okay, this will cancel, minus 5 by 8x equals to 1. So if you calculate here, so 2 4 is 8, so 4 is 20 minus 5 15, 15x by 8 is equals to 1 minus 5 by 8 is 3 by 8, right? Okay, so you get x equals to 3 by 15 or 1 by 5, so that will be equals to 200 ml, right? So what is the answer? See, how many of you got correct? So next, this question I need to make you understand what is ppm and how ppm is calculated. So listen very carefully, okay? See, ppm is always generally calculated in the equivalent to ppm of CaCO3. Say 10 ppm of MgCl2 is present, but for standardization we will calculate its equivalent to how much ppm, how much ppm of what? CaCO3. I will also tell the reason why. How we can do that? So let us see. So the options for this question are: option A 12.25, option B 14.30, option C 16.10, 16.40, option D 20.12. Calculate. 3 2 1 start. First I am giving you the explanation of this. Say MgCl2, okay, what is the molecular weight of MgCl2? 24 plus 71 95. What is the N factor of MgCl2? What? 2. So this is the equivalent weight. This will be, this much ppm will be equivalent to what is the weight of CaCO3? 40 plus CO3 I told you to remember 60 by N factor 2, because Ca 2 plus. That means this 2 cut, 95 ppm is equivalent to 100 ppm of what? CaCO3. 95 ppm of what? MgCl2. So you can convert it, right, to CaCO3 equivalent, right? Now if you have here KCl, suppose this contributes to hardness, and this you need to make it in CaCO3 equivalent. This is x ppm. How much ppm it will be? See, weight 39 plus 35.5, so basically it's coming 69, 74.5. What is its N factor? 1 is equivalent to this much ppm is equivalent to Ca 40 plus 100 60 100. See, why CaCO3 equivalent is taken? Because its weight is 100. That is very easy to convert by 2. That means 74.5 ppm of KCl is equivalent to 50 ppm of what? CaCO3. Right? So you have understood. Now come to the question. Let me erase all this. Why it's not coming? This thing, no. Why it's not coming, you say? Oh. So wait a bit. Eraser, and I'm erasing all this. We can make the calculation. Make space. Go 3, go dot, go 3, all go, get lost, option don't get lost, okay? So we have made it. Now we'll do here pen. See, what is the pen? Okay, so let me start the calculation. This one we have calculated 95 ppm is equivalent to 100. So that means how much 10 ppm will be equivalent to? This will be equivalent to 10 by 95 into 100 ppm. That will be equals to, cut it by 5, 17, that means, sorry, 19, 200 by 19 ppm, right? Let it be like this. After all we will add. Now second one, for CaCO3, what is the weight of SO4? Quickly, 96. How 96? H2SO4 we know is 98. We have read it much in many places. 2 minus for hydrogen, so it is 96. 96 plus calcium 40. That means 136 ppm by 2. Why 2? In factor of CaSO4 is 2. Is equivalent to 100 by 2 ppm of what? CaCO3. And it is of CaSO4, right? So 136 ppm is equivalent to 100 ppm. How much 8 ppm will be equivalent? Unitary method you have done in class 2. You have started doing from class 2, I guess. 136 by 8, sorry, 8 by, भैया क्या कर रहे हो आप? 136 into 100, कितना easy calculation है? 1s are 8, 56 7, so it's 7 800 by 17 ppm. Now you add, total equals to 200 by 19 plus 100 by 17. 17 6 is 102. Let me take it 6, okay? And 200 by 19, 19 ones are 19, 1 in hand, 10, it's not usable to put it 0, 100, 19 5s are 95, okay, and 15 hand, so let it be till this. So it's coming 16.5. Since we have taken it little bit more, so the answer must be little bit less than 16.5. Is there any option? Yes, 16.40. Have you got it correct? Huh? Answer me. These two questions, I have said to you, these two questions has come in WBJEE. Solve this. These are not related to this one, but you will solve it. This is, I think, limiting reagent sum. 5 ml of 0.1 molar PbNO3. Don't take it as a homework. Take it as a classwork. Do it right now and answer right now in the comment box. I want to see the answers. Okay. So 5 ml of 0.1 molar lead nitrate is mixed with 10 ml of 0.02 molar potassium iodide. The amount of lead iodide that will be precipitate: 10 to the power minus 2 mole, 10 to the power minus 4 mole, 2 into 10 to the power minus 4 mole, and 10 to the power minus 3 mole. This is a very basic question. In the crystalline solid MSO4, unknown metal MSO4.NH2O, molar mass is 250. It is given molar mass. The percentage of anhydrous salt is 64 by weight. That means percentage is by weight, means say if MSO4's weight is something, say X, total weight is 250, okay, into 100 is equals to 64. Not that MSO4's weight is equals to 64. Don't do that mistake, okay? Then M will come in negative. That is not possible. So tell me the answer of these two questions quickly. So bye bye, have a nice day, study hard, and don't watch IPL.